In this video, we're going to talk about how we communicate extreme numbers. So I'm talking about really, really big numbers or really, really small numbers. When I say really big numbers, I'm talking about numbers like 5 billion or even way bigger. And when I say really small numbers, I'm talking about really, really small decimals, like 0.00000000008. Really, really tiny. And as we know, numbers can actually go on forever in either direction, so I'm talking about numbers way, way bigger than this and way, way smaller than this. But those wouldn't fit on my screen. And that's the point of this video. So we need a way to communicate numbers that are super big or super small without having to write out all these digits or having to read all these digits to figure out how big or how small that number actually is. The more zeros or decimal places we add here, the harder it is for our brains to look at these numbers and actually see them for what they are. So we have a system for that. It's called scientific notation. And here's where I'd like to start your note in your mathematical thinking journal. We're going to talk about scientific notation, and I want you to have these examples down. So before we get into the examples, I want to talk about this name, scientific notation. So it comes from the term science, obviously. And in science, we talk about really big and really small numbers all the time. For example, the size of an atom, that's really, really small. Or the size of the solar system or the universe, it's really, really big. We need a way to communicate these numbers. Like the speed of light is super fast. It's a huge number. It's not going like 60 kilometers an hour. It's going astronomically faster than that. We need to be able to communicate all of these numbers in a way that makes sense for our brains and also doesn't take a million years just to type into a calculator. So scientific notation is our solution for that. So scientific notation is just a convenient way to communicate extreme numbers. So grab your calculator and try this for a second. In your calculator, type in 1,100,000 and then squared. Should be a little button that looks like this. Now keep hitting that button. Something should happen on your calculator screen. So instead of showing all of those digits, it's going to start to look like a different kind of number. You should have 1 times 10 to the power of some number, depending on how many times you hit this button. Your calculator screen is not very big when it comes to numbers. It can only fit a certain number of digits. So most calculators will switch into scientific notation when the numbers get too big. So let's talk about how we can switch into scientific notation when the numbers get too big. So let's look at our example from before. We'll start with a really, really big number. Start with 5 billion, which in the grand scheme of numbers is actually not that big, but for us that's a pretty big number. It's really too big for our minds to comprehend. So let's start here. 5 billion. Now with every whole number, there's a decimal place at the end, and that's important for scientific notation. So in order to make this number a little more convenient, the first thing we're going to do is we're going to look to move that decimal place so there's only one number before it, not a whole bunch. So I'm going to move this decimal. I'm going to move it right here. And then I'm going to see how many times I moved it. When you're moving it, it's easy just to count. That's why I use these bumps. But let's count now together. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I moved the decimal place 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9 to get to where it is. So now I can write my number in scientific notation. It would be 5 times 10 to the power of 9, or however many times I move my decimal. Let's move that over here. Now let's try one that's very, very small. Let's try 0.00000000008. Now, just like in the last example, we need to move the decimal place so there's only one number before it. In this case, that's 8. Let's see how many times we move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this one, 8 times 10 to the power of 11, but this is a really small number, not a really big number. We moved the decimal place to the right, so we're actually going to make that negative 11. And you can try this in your calculator too. So if you have a decimal, it's going to be a negative power. Try putting in a really, really small decimal. So 0.00000000642 and see what you get. Your calculator probably doesn't have space for all those digits. So what's going to happen is it's going to put it into scientific notation. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. It should be something like that. And you'll notice I didn't include 4 and 2. I put the decimal place after the very first number. So that's important to remember. There's only one number before the decimal, and then any other numbers following are totally fine. Sometimes you might have to round, but usually 2 decimal places is good. So let's recap those steps here for scientific notation. I'm going to remove all of this here, so if you'd like to copy it down, pause the video, otherwise it's going away. I would say the most important part here are these examples. Write these down here, and then we'll summarize the steps. So steps to converting to scientific notation. First thing you're going to do is move the decimal. You want just one number before it, and then you can round the rest. Next, you're going to count your moves. How many places did you move the decimal? And 3. You're going to write it out with times 10 to the power of the number of moves. Let's do one more example. Let's say we're working with the number 415,790, and I want that in scientific notation. So the first thing I'm going to do is I'm going to move that decimal 1, 2, 3, 4, 5 places. 1, 2, 3, 4, 5 places. So it would be 4.1579, don't need the 0, times 10 to the power of 5. If I wanted to round, this 5 is going to row up because the next number is 7. So it's 4.16 times 10 to the power of 5. So that's the same number, just communicated in scientific notation. Let's do one more super tiny number. First thing I'm going to do is move the decimal 1, 2, 3, 4 spaces. And that gives me 5.82 times 10 to the power of 4 in scientific notation. Oh, this would actually communicate a very big number. I missed a step. We're actually communicating about a tiny number, so I need my negative here.